Alright, so we're here now to do part B of the pendulum experiment. This time we're going to look at the effect of changing the release angle on the period, and as we've talked about, we started by looking at the pendulum in the small angle approximation, but we've also worked out the theory in the case where for all angles. So the setup we have is basically the same as it was before. We have, once again, our pendulum bob and our photogate. What's new this time is that I've set up this horizontal meter stick that'll let us measure the release angle more precisely than I could with a protractor. Now, the first thing that I need to measure is how far down the meter stick is from the support of the pendulum. I'm just going to look at our manual, just what did we decide to call that quantity. And we're calling that y. So we're going to, so part B, writing in my lab notebook. So I'm going to make a sketch of this situation here. So we have our bob and our meter stick. Okay, I've got a little sketch here. It's going to measure y with another meter stick. So let's climb on up here and okay. And putting up from the top of the support there and measuring to the top edge of my meter stick. That's about 67. Call that 67. 67.2 plus. This one's a little easier because the edge. I have a nice clean edge. Let me call that plus or minus 0.3 centimeters. Let me do that one more time just to confirm it. 60, so yeah, it's about 67.2 plus or minus 0.3 centimeters for the distance between the top of the support and the meter stick. We'll also need the length of our pendulum here, so I'll call that L. And once again, we'll measure from the top here. I have to crouch down so I can read without parallax. And again, this is about 75. Read that one more time. So I'm sure about how to wrote this. Yeah, let's call that 75.1. It's a little more uncertainty here because of finding the center mass of the bulb. Let's call that 75.1 plus or minus 0.4 centimeters. All right, so everything else is as before. What I've done now is we want to get the most precise measurement to the period that we can. I've actually cranked up the frequency of our clock. It's now 4 kilohertz. You can see that that's now narrower. If I on the scope, if I turn this down to 250 microseconds, that's in fact one period. So 250 microseconds per division is one period. All right, so let's give this a go. So we'll start by measuring this for a large-ish angle. So what I'm going to do is I'm going to release, so right now, the one with my pendulum bob hanging straight down. Let's see where our meter stick is reading. So with the string hanging straight down, we're at 50 So 59.6. Call that x1. Call that 59.6 plus or minus. Give that about 0.3 centimeters, making a fairly conservative estimate of the uncertainty. When we pull it back, I'll pull it back to a certain point here. Again, measuring from sort of the top, where the top of the string crosses the top edge of my meter stick. I'll read that off. I'm going to aim for right now 5, let's call that 4 centimeters. So that'll give us a swing of close to 45 degrees. So let's try, so run 1, so x0, I'll call that 5. And this is going to be tricky to do, so I'm going to 5.0 plus 1 is 0.5 centimeters. All right, so what we're going to do is we're going to pull it out, release it, and then time. I'm going to check that right now this meter stick looks like it's pretty level, so we don't have any systematic errors coming from there. I've just turned on my measurement circuit. I'm going to clear timer here. We're at 4 kilohertz. All right, so let's see if we can do this. I'm going to pull the spring out to about 5, and that's about 5 centimeters, and I'm going to let this go straight. And it's swinging, and let's time, and now. Okay, we have now reading, we have the reading, I'm going to try not to get whacked by this. We have the reading on our hex indicator is upside down U, so that's period equals C as in Charlie, 5, and then C, 5 alpha. So that's, so repeat, C, 5, A, that's Charlie, 5 alpha. So we've got the symbols as U, a 5, and a sideways C. All right, let's repeat the measurement. We're going to repeat this a couple of times for each initial angle. Okay, so I'm going to catch this now. I'm going to again aim for 5 here. Try to release that straight. Good, all right. Timer is cleared, and we'll start timing now. Okay, and that just stopped. It hit the post, but we got a measurement. This time we measured, let's actually do, I want to do that one just again because it hit the post. So we'll keep filming, but this is experiment, this sort of thing happens. I'm going to clear the timer. I'm going to reset this to straight. Set at 5. That's a no-go. Okay, let's try this again. Okay. And let's go. Okay. This time we have measured that is C as in Charlie, and 4, and Charlie for 11, Charlie for Bravo, hex, that's, yes, Charlie for Bravo hex, C for B. All right, just because this is a little tricky, let's do this, measure this one more time. I'm going to clear the counter here. I'm going to relaunch our pendulum, catch it, try to keep this spring from catching here. And we'll pull it back to 5. Okay, so apparently we had a minor technical difficulty there, but we're back. So we had measured periods for two angles. No, sorry, we had measured for the largest angle, we'd measured the period twice. I want to do one more measurement to give us a sense of the uncertainty in the period at this angle. So let's do that now. Our counter is cleared, our clock is still at 4 kilohertz. Let's go and rake this up, pull it out to 5-ish centimeters here. Try to release it straight. There we go. And we're ready to time it. Okay. And we have now measured. So Charlie 3, F as in Foxtrot, Charlie 3, F X. And I can kind of see that at this point the period, air resistance and friction have reduced the period. Let's just measure this one more time to give us a sense of what's going on. Just to be safe, we'll have a total of 4 measurements at this initial release. Here. And there we go. All right, this time we have Charlie 7, Charlie 7, Charlie Hex. So we have 4 measurements. We have some spread here, but that'll come into our uncertainty calculations. All right. All right, so continuing with the pendulum procedure, now we're going to go for a smaller angle. Let's call this run 2. And I'm going to this time release when the string is at x, what I'm going to call x0 equals 15 plus or minus half a centimeter. I'm going to check that this stick is still basically level, more or less. Okay. This time I think you've seen the whole procedure, so I may not film every little step here, but I'll just do one run and then I'll just tell you what I measured when I did it a couple more times. All right, so without further ado, our counter is ready to go. It's cleared. Our clock is still hasn't been changed, it's still at 4 kilohertz. All right, let's do this. I'm going to pull the string out to now about 15 centimeters and release the dice. Try that again. 15. I'm swinging, and we're going. Okay. I want to do that again. I'm not sure if I caught it correctly. Let me just do that one more time. 15. And that's a hit. Okay. All right, this time we have Charlie, period is Charlie 3, 0, hex. All right, and I'm gonna now just repeat this a couple more times. All right, so we're now ready to do another angle. This is gonna be run 3. Now x0 is 25 plus or minus 0.5 centimeters. I've written that down. Clock is still the same. I've cleared our counter. Let's go and take a look. All right, 25. I'm trying to release this straight and keep my hand steady. That and ready for time. Okay, this now gives me a period of Bravo Foxtrot 0. Thanks. Bravo Foxtrot 0. And once again, as with the last set of measurements, I'm going to now repeat the measurement a couple of times and then just tell you what happened. All right, let's do another angle. This is run 4. I'm going to this time release the pendulum. Let's just say that we do it at 40 centimeters on the scale here. Clear my timer. My clock is still 4 kilohertz, so let's go to 40. And this is now a much more modest angle. And we'll let this go. And time. Okay. We have now measured a period. And that is now Bravo. Bravo. Flip everything up. That's Bravo 8. And Bravo 8 Alpha. Bravo 8 Alpha. All right, I'm going to just repeat the measurement a couple more times, and I'll tell you what happened. All right, we now have one last angle to do. This time, I'm going to release this at a quite small angle. Let's do this at x0. Let's do 55 centimeters. Right. Clock is still the same, timer's been cleared. This time I think I can just do it by eye. And where would it go? And time. Okay. This time we have a period of Bravo 4 Charlie, hex B for C, Bravo for Charlie. All right, we'll just do this a couple more times and I'll tell you what happened. All right, that's all the data we need for part B of the pendulum experiment. We have now measured the period for 5 different initial release angles, and I will have the data posted for you. So in our last part of the experiment, we're going to think about whether or not the mass of the pendulum bob has any effect on the period. Thank you.